Right now, across global networks, an invisible heist is actively siphoning up massive quantities of data every single second. But the criminals and state actors behind these operations are currently stealing files they have no way of reading. They are sweeping up everything from private individual messages to highly classified government intelligence. Today, this stolen data is protected by encryption that functions as a computational wall, scrambled into a form that no existing processor can return to a readable state. The thieves are hoarding these files anyway, betting on a specific technological shift that will make this encrypted data readable in the future. This strategy is known as a store now, decrypt later attack. The attackers are waiting for the development of a processor powerful enough to bypass the mathematical barriers currently protecting this information. That processor is being built right now in research labs across the globe. This threat comes from the development of workable quantum computers. When these machines reach a certain level of sophistication, the mathematical foundations of nearly every digital security system on Earth will become obsolete. To understand why these new computers are so disruptive, we have to look at how we currently scramble data. Modern encryption relies on equations so complex that they are effectively impossible to reverse engineer using standard logic. Current supercomputers try to solve these equations by guessing one combination at a time, moving through a sequence of billions of possibilities. For our most powerful classical machines, reaching the correct answer would require thousands of years of continuous processing. Our current security depends entirely on that timescale, the fact that the math is simply too tedious for any existing computer to solve. Quantum computers operate on different physical principles that allow them to process these vast calculations in parallel. Instead of checking one combination after another, a quantum processor can effectively explore all possibilities simultaneously. A calculation that would take a classical computer millennia could be solved by a quantum computer in a fraction of that time. For a long time, researchers believed we were decades away from seeing these machines perform at this level. However, Google recently announced that advances in hardware and control technology have accelerated the timeline significantly. This means the sudden collapse of current internet security, a scenario often called the quantum apocalypse, is much closer than we realized. This realization has triggered an urgent effort to rebuild the internet's underlying defenses. The industry is moving towards post-quantum cryptography, or PQC. These are entirely new mathematical frameworks designed to be specifically resistant to the unique way quantum computers process information. Implementing this requires a complete foundational replacement of the security protocols used by every server and device on the planet. Google has now set 2029 as the hard deadline for completing this transition within its own systems. This timeline serves as a signal to the rest of the industry that the window to protect global data is closing faster than expected. Any information that is not moved to these new standards before quantum processors mature will be exposed to those who have been hoarding data for years. The technical community is now in a sprint to deploy these new mathematical defenses before the computing power capable of breaking the old ones arrives.